Good morning, afternoon, or evening, regarding the time you are seeing this. Greetings to all of you. This talk is coming under Project ARC-C that stands for Assuming Responsibility for Climate Change. The project aims to fully align its outputs to a collective response towards climate change, using the combined efforts of 14 partners representing 13 countries, funded and supported by the British Council under the open call for creative commissions. I am Dunya Wafa. In 2019, I graduated from College of Biotechnology, Master University for Science and Technology, currently working there as a teacher assistant in Environmental Biotechnology Department. In March 2020, I got enrolled in the first batch of the Adaptive project supported by Erasmus Plus program to get my Master of Science degree in Climate Change Management through Mitigation and Adaptation. Here I am this semester finalizing my thesis and in isolating and identification of low-density polyethylene biodegrading bacteria from the Mediterranean Sea. But first, excuse me. Okay, the Mediterranean, the marvel and the villain. Before we start, let's state some facts. Did you know that more than 1 million seabirds die from plastic pollution every year? Over 90% of all seabirds have plastics in their stomach. Marine plastic pollution has affected 100% of marine turtles, 59% of whales, and 36% of seals, and 40% of seabirds of those examined. Did you also know that 100% of baby sea turtles studied have plastic in their stomach? Sea turtles, by caught in fisheries operating within and around the patch, can have up to 74% by dry weight of their diets composed of ocean plastics. Animals consuming plastic can starve to death, as the plastics fill their stomach, preventing them from eating proper food, rupturing their organs, or blocking food from traveling to the intestine. Further, 705,000 tons of discarded fishing nets drown sea mammals, and in the Great Pacific Garbage Patch that covers a space of 1.6 million square kilometers containing 8 trillion bits of plastic, 46% of which is made up of fishing nets floating between Hawaii and California, threatening thousands of animal species. Moreover, did you know that if corals encounter plastic, its likelihood of becoming diseased increases from 4% to 89%, as corals are home to more than 25% of marine life. Along with the large items of plastic being ingested and entangling wildlife, the plastic debris blocks plankton and algae from receiving sunlight, as they produce nutrients for other creatures, and if their existence is threatened, the entire food web may change. Last but not least, did you know that 1 in 3 fish caught for human consumption contains plastics? Endocrine disruptors like bisphenol A, PBA, a chemical compound used in manufacture of various plastics, will increase our risk of certain cancers, causing hormonal issues, and even increase the risk of infertility and birth defects. Before we go further in our topic, let's highlight some terms. First, climate. It means the conditions of the atmosphere at a particular location over a long period of time. It's the long-term summation of the atmospheric elements, as solar radiation, temperature, humidity, precipitation, atmosphere pressure, and wind. So, what is climate change? It's the long-term change in the average weather patterns that have come to define Earth's local, regional, and global climates. Change observed in Earth's climate since the early 20th century are primarily driven by human activities. This drives us to one of the climate change causes, which is plastics. Plastics are a wide range of synthetic or semi-synthetic materials that uses polymers as a main ingredient. Plastics are of several types, Here, this table shows the 7 types of plastics, their identification code, abbreviation, recyclable or not, their decomposition rate, and so on. But one type in particular is our main concern, the low density polyethylene, LDPE4, that makes up to 36% of plastics thrown into the ocean, with a decomposition rate of 500 to 1,000 years under perfect conditions. The low-density polyethylene accounts for 16% of plastic production by type, coming as the first and highest produced polymer based on 2017 production data. Low-density polyethylene goes on several everyday single-use plastic products as hot and cold beverages, cups, garbage bags, sandwiches bag, plastic wraps, and so many others as listed below. Although low-density polyethylene is considered less toxic than other plastics, it, however, contains estrogen-mimicking chemicals that can disrupt hormones and potentially alter the structure of human cells. Plastic pollution and climate change. Marine plastic pollution and climate change are fundamentally linked. Plastic pollution has an equally global distribution. It's found across all regions of the ocean, from shallow coastal areas to the deepest region sampled to date, and in the most remote and sensitive locations on Earth. Climate change is a major global threat, already affecting every region across the world and displaying increased ocean temperatures, sea level rise, ocean acidification, currently influencing the distribution of plastic pollution, and will spread further with climate more frequent and extreme weather events that are causing widespread ecological and socio-economic harm that is predicted to intensify. But how does the climate change really contribute to plastic pollution? If you have ever lost your hat or a pair of sunglasses in the ocean, then you know that the sea does not stay still. If you didn't retrieve the lost item immediately, it was likely well on its way to the other side of the world, carried away by ocean currents. Ocean currents may be driven by tides, winds, or differences in densities. As these currents travel, they pick up sediments and transport it down the beach in a process known as a longshore drift. Here, the map and the map key at the bottom shows the mismanaged land plastic waste as tons per year. If you concentrate on the Mediterranean, we will see Egypt colored in a baby blue color with more than 10,000 tons of mismanaged plastic waste per year, releasing more than 5 pounds per square meter of mismanaged plastic waste into the Mediterranean that will eventually end up in the ocean by the aid of currents. But still, how does climate change really contribute to plastic pollution? This drives us to the Great Pacific Garbage Patch. It is the world's largest collection of floating trash, also known as the Pacific Trash Vortex, spans water from the west coast of North America to Japan. The patch was discovered in 1997 by Charles Moore, a yachtsman who had sailed through a mishmash of floating plastic bottles and other debris on his ways home to Los Angeles. These areas of spinning debris are linked together by a North Pacific Subtropical Convergence Zone, located a few hundred kilometers north of Hawaii. This convergence zone is where warm water from the South Pacific meets up with the cooler water from the Arctic. The zone acts like a highway that moves debris from one patch to another. The entire Pacific Garbage Patch is bounded by North Pacific Subtropical Gyre. Gyre is a large system of swirling ocean currents. The North Pacific Subtropical Gyre is formed by 4 currents, rotating clockwise around an area of 20 million square kilometers. The California Current, the North Equatorial Current, the Kyushu Current, and the North Pacific Current. The circular motion of the gyre draws debris into the stable center where it becomes trapped. For example, a plastic water bottle discarded off the coast of California, for instance, take the California Current south toward Mexico. There, it may catch the North Equatorial Current, which crosses the vast Pacific. near the coast of Japan. The bottle may travel north on the powerful Kuroshio current. Finally, the bottle travels eastward on the North Pacific current. This describes how plastic waste moves from side of the world to the other. On the other hand, how does plastic pollution contribute to climate change? After plastic items have been consumed or used, these items may follow several different routes: landfills, dump sites, or escape into the environment. Plastics can escape in the environment at every stage of their life cycle, during production, transport, or conversion. Plastic pellets or fibers may be lost. An estimated 19 to 23 million tons of plastic waste entered aquatic ecosystems from land-based sources in 2016. Annually, 154 million pounds of plastic is incinerated, releasing toxins into the air, leading to a rise in the greenhouse gas emission, speeding up and intensifying the effects of climate change. Plastic pollution is more than just waste that is discarded and left to rot in the environment. Its production is also contributing to air pollution and global warming. Even as we try to curb fossil fuel use in sectors such as transportation and heating, consumption of plastics will only increase based on our current trajectory. The Center of International Environmental Law estimates that if trends continue, plastics will account for 20% of the oil consumption by 2050. Also, the expansion of plastic production is estimated to emit over 56 billion metric tons of carbon dioxide in greenhouse gases between 2015 and 2050, which is 10 to 13% of the entire remaining carbon budget. Further, all conventional plastic ever made is still with us on the planet, except if it is burned. Almost a third of plastic waste, from 93% of the world's population, was classified as mismanaged in 2010 and is predicted to reach up to 90 million metric tons per year entering aquatic systems by 2030 under business as usual scenarios. Much of the plastic that does not make it to the recycling plant ends up in our rivers and oceans. Most plastic is incinerated or dumped into landfills, where it leaks toxic chemicals into the soil, ending up in our food and water supply, causing developmental, neurological, or reproductive disorders, which can be detrimental to animal and human health. Numerous chemicals used to produce plastics as PBA were found in 95% of US adults, and these chemicals are known to be carcinogenic and to interfere with the body hormone system. Moreover, floating plastic marine debris can negatively impact marine life and provide transportation for invasive species. As waste floats across the sea, it carries non-native bacteria and other organisms to new locations where they can particularly be harmful. Ocean plastic pollution has helped quadruple the number of dead zones found in our waters. Dead zones are areas in marine environments that suffer from low oxygen. These low oxygen levels can cause marine animals to suffocate, leading to their extinction and causing an ecological imbalance. Lastly, many marine animals accidentally ingest plastic waste or microplastics. According to a 2019 Reuters infographic, humans ingest about 5 grams of plastics every week, a spoonful that weighs about as much as a bottle cap and equivalent to about half a rice bowl. The Mediterranean Sea. Every year, 0.57 million tons of plastics enters the Mediterranean waters. This equivalent to dumping 33,800,000 plastic bottles into the sea every minute. Without action, this number will keep growing as plastic waste generation in this region is expected to quadruple by 2050. 22 countries and territories comprising the Mediterranean region produce 10% of all plastic goods, making it the world's fourth largest plastic producer. Plastics are creating a serious challenge for nature, society, and the economy. Plastic waste is damaging the Mediterranean ecosystem. Plastic pollution kills aquatic wildlife, damages natural systems, and contaminates marine food chains. Globally today, over 700 marine species, including sea mammals and birds, are impacted by plastic through ingestion, entanglement, or habitat degradation. The international maritime and fisheries industries abandon those or discard gear and other equipments in the sea. This damages marine habitats and kills wildlife. In the uncontrolled and potentially leaked into the nature of the waste collected, 17 point Mediterranean plastic pollution and ghost fishing caused the injury or death of sea birds. It causes the death of 27% of fish, 20% of invertebrates, and 13% of marine animals, and 5% of reptiles. The Mediterranean's prosperous blue economy represents 6% of the region's GDP, but loses an estimated of $641 million to marine plastic pollution each year. Tourism, maritime trade, and fisheries are directly and adversely impacted by plastic pollution. Tourism accounts for over 3/4 of the current Mediterranean Sea economy, with maritime trades and fisheries producing the remainder. The international maritime The international maritime trade and fisheries industries account for 20% of the plastic entering the Mediterranean Sea each year. In contrast to global ocean, 80% of maritime plastic pollution in the Mediterranean returns to land within a decade, polluting beaches and coastlines. Coastal activities contribute to half of plastic entering the Mediterranean Sea, and 30% arrive from lands via rivers. Turkey's Sicilia's region has the highest coastline pollution in the Mediterranean, followed by the coastal areas surrounding Barcelona and Tel Aviv, and other city hotspots including Valencia and Alexandria and the Venice coast close to Revel Delta and the Bay of Marseille and the Nile are the most contaminated rivers, feeding plastic into the sea. Mediterranean countries generate 24 million tons of plastic wastes every year, managing only 72% through controlled waste treatment, with some countries performing better than others. Of the waste generated, 20.4 million tons means 85% are collected, leaving 15% uncollected and potentially leaked into nature. Of the waste collected, 72% is managed through controlled waste treatment, 42% end up in the controlled landfills, and 14% are incinerated, and 16% are recycled. The remaining waste is mismanaged, with 1% ending up in landfills that do not respect the minimum sanitary requirements, and 12% dumped illegally. 3 Mediterranean countries account for 2/3 of plastic leaked into nature. Every Mediterranean country is mismanaging a portion of its wastes. But given their plastic production and consumption pattern, size of economy, and current waste management system, the biggest contributors to the mismanaged waste in the region are Egypt with 42.5%, Turkey with 18.9%, and Italy with 7.5%. Moreover, a total of 6.6 million tons of plastics waste is mismanaged yearly around the Mediterranean. Almost half of the region's total amount of mismanaged waste is accounted for Egypt, followed by Turkey, Italy, Algeria, and Morocco. Those that mismanage the highest proportion of their waste streams are Montenegro, Egypt, Albania, and Libya, and Egypt comes with a 93%. Egypt and Turkey are the two of the largest sources of open dumping by total volume, dumping 1.3 million tons and 0.8 million tons of untreated plastic waste into open sites each year. The Mediterranean countries recycled 3.9 million tons of waste in 2016, but recycling rates vary across the region. Italy had the leading recycling industry in the region by size. France is close second, followed by Spain. Across all the Mediterranean countries, only 17% of wastes get recycled. This remains behind the European average of 31%. Lastly, more than half of plastic becomes waste in less than a year after it was produced, and almost 1/3 of the Mediterranean plastic waste is mismanaged. This plastic, which either remains uncontrolled or end up in illegal landfills and open dumps, is mostly like to make its way into rivers and eventually into the sea. Analysis shows that conventional ways of handling plastics as landfilling, incineration, pyrolysis, gasification, and hydrothermal liquefaction altogether contribute to emitting greenhouse gases. As in 2015, US emissions from plastic incineration was 5.9 metric tons of carbon dioxide, and these are expected to increase to 91 million metric tons by 2050. Further, the byproducts of plastic degradation using conventional methods are toxic irritants and harmful gases formed that not only damage the ozone layer in the upper atmosphere, but also destroy the underground water resources, causes infertility of soil, and are proved dangerous to human, animals, and the ecosystem. Recent researches suggests that there are a lot of microbial species that can degrade synthetic polymers at faster rates due to the presence of natural catalytic enzymes that break apart the strong hydrocarbon bonds in the plastic materials without the drawback of conventional methods. The aim of my study, my thesis, is to isolate and identify bacterial strains that are capable of low-density polyethylene biodegradation to tackle the climate change dilemma caused by the mismanaged plastic waste leakage into the Mediterranean, in particular the low-density polyethylene. Through our research, Mediterranean Sea will serve as the area of interest where the isolation and identification of low-density polyethylene biodegrading bacteria, paving the way for developing innovative strategies for plastic degradation and moderating environmental impacts of the plastics with an economically feasible approach. Hope you enjoyed the talk, and don't hesitate to contact me for any further inquiries. Thank you and bye-bye.